Hi, my name is Regina Norton, and today I'm going to explain the theorem of Thales. First, I want to explain what this theorem is about. The theorem of Thales said that when we have two parallel lines that cut two lines, the segments that are formed are proportional. This means the parts have the same radius. In simple words, if two lines are parallel, they divide other lines in the same proportion. Now I will explain why this works. When parallel lines cut two sides of a triangle, they create a smaller triangle inside the big triangle. The angles stay the same because their lines are parallel. When triangles have the same angles, they are similar triangles. Similar triangles have the same shape but different size, and when triangles are similar, their sides are proportional. That is why the theorem works. It works because the triangles formed are similar, and similar triangles always have proportional sides. Now I will show an example. Imagine we have a triangle. We draw a line parallel to the base. This line cuts the two sides of the triangle. One, the left side, the small segment measures 3 centimeters, and the whole side measures 6 centimeters. One, the right side, the whole side measures 8 centimeters, and we want to find the small segment. We will call it x. Because the line is parallel, the lines are similar, so we can write a proportion. 3/6 is equal to x over 8. Now we solve it step by step. First, we simplify 3/6. 3 divided by 6 equals 1/2. So now we have 1/2 equals x over 8. Now we multiply cross. 1 times 8 equals 8. 2 times x equals 2x. So we get 8 equals to x. Now we divide both sides by 2. 8 divided by 2 equals 4. So x equals 4. This means the small segment on the right side measures 4 centimeters. And this makes sense because the triangle is growing in the same proportion on both sides. When I first learned this, I thought it was just about moving numbers around, but actually it's about understanding similarity. Once you see that the triangles have the same shape, everything becomes logical. So to finish, the most important idea is, if parallel lines cut two sides of a triangle, the segments are proportional, and this happens because the triangles formed are similar. Thank you. After solving the example, I want to explain something important that I forgot to mention. Many students think this theorem is just about writing fractions, but it is not only about fraction, it is about understanding similarity. Let me explain this more clearly. When we draw a line parallel to the base of a triangle, we are not changing the shape. The similar triangle at the top has the same angles as the big triangle. The only difference is the size. Because the triangles are the same, the triangles are similar. And similarity means that every side grows or shrinks in the same proportion. For example, in our program, the left side goes from 3 to 6. 6 is double of 3, so the whole side is twice as big as the small part. If the proportion is correct, the same must happen to the other side. If the big side is 8 and we divide it by 2, we get 4. And that is exactly the value of x. So we can even check the answer using logic. 3 becomes 6, so it multiplies by 2. 4 becomes 8, so it also multiplies by 2. This confirms that the proportion is correct. Okay, now imagine another situation. Suppose the small segment on one side measures 4 centimeters and the whole side measures 10 centimeters. On the other side, the whole side measures 15 centimeters. We want to find the small segment. We write 4 over 10 is equal to x over 15. Now, we simplified 4 over 10. 4 divided by 10 equals 2 over 5. So now we have 2 over 5 equals to x over 15. Now we multiply cross. 2 times 15 equals 30. 5 times x equals 5x. So we get 30 equals 5x. Now we divide both sides by 5. 30 divided by 5 equals 6. So x equals 6. Again, this works because the triangles are similar. So the theorem of Thales is powerful because it allows us to find distances without measuring directly. It is used in architecture, design, engineering, and even in maps. When we understand why it works, mathematics feels more logical and less scary. And honestly, once you understand single triangles, this theorem becomes simple and very useful also in your daily life.